Three students from a class of 10 are to be chosen to go on a school trip. How many ways can they be selected using this formula? So we have 3 students from a class of 10. Is that a combination or permutation? 3 students get to go on a class trip. Combination. Now, if you gave them different jobs on that class trip, it would be a permutation, right? So the fastest way to do it for us is 10 combination 3. You have 10 students, you choose 3 to go on a trip, and it's a combination, because order doesn't matter. Then we have formulas on our formula sheet. This is the formula on our formula sheet on the bottom left-hand side. NCR equals n factorial over n minus r factorial, r factorial. So this is n, this is r. So we're going to get 10 factorial all over 10 minus 3 factorial, 3 factorial. I'm just filling it into that formula, right? Nothing crazy, nothing fancy. Yeah? So then I technically end up with 10 factorial. 10 minus 3 is 7 factorial, 3 factorial. So this is where you're going to use the alpha link, or you're going to use second y equals enter to get the fraction button to pop up. If you don't have that option, you're going to use brackets if you have a TI-83 or a fake TI-83. Yeah, still you. So 10 factorial divided by 7 factorial, 3 factorial. Type it into your calculator. What do we get for an answer? Some of you have typed it in. Yeah? 120? So there are 120 different ways you could pick it for a trip. Yes? Now, what if there was 3 different trips you could go on? That would be 10p3, correct? So we could use a formula for that. I'm going to show you another way that you can do 10c3 without the formula. If it said algebraically, you'd have to show this formula, right? If it doesn't say algebraically, you can type it in. So go 10 into your calculator, 10, and you're going to go the same spot where the factorial symbol is. So 10, math, arrow left. Instead of picking number 4, you're going to pick number 3, NCR. And then you put 3, enter. Dude. You get the same thing? Okay. Now do the same, but do it with a P. So go 10, P3. So now you're picking number 2 instead of number 3. Is it bigger?
Yeah.
It should be, because 10C3 is this formula. Watch this. It's just a caveat because this isn't actually a question. 10P3, guys, is the exact same. This represents the number of blanks for fundamental counting principle. So 1, 2, 3 blanks. You see that? This represents the number you start with and no repetition. So it'd be 10, 9, 8. So this is 720. Okay? So there is a difference between the P and the C. P order matters, C it doesn't. The P formula also doesn't have this. The P formula doesn't have this R factorial in the bottom. So the P formula is actually 10 factorial over 7 factorial. And we don't divide by that 3. So that's why it's bigger, is a bigger answer as well. Because this gets rid of all the cases where that order doesn't matter. Just like that factorial, then when we had repetition of letters, does the same thing. It basically takes the permutation formula and divides out the places where it's not different. Okay, now, only with C's can this happen. 10C3 equals, now if you look down here, it says NCR equals NC n minus R. So the difference between the two. So 10C3 would equal 10C7. I'm going to show you how, and it only works with the C formula. Okay, everyone watching, so it actually makes sense why it works? Okay. So we did the 10C3 formula. It was 10 factorial over 10 minus 3 factorial, 3 factorial, which was 10 factorial over 7 factorial, 3 factorial, right? Now we're saying that these are the same, so they should equal each other in the end, yes? Well, now my n is 10 and my r is 7. So I'm going to get 10 factorial over n minus r, so 10 minus 7 factorial, and then r factorial, which is 7 factorial. So now I get 10 factorial over 3 factorial, 7 factorial. Those are the same answer, are they not? Because 3 times 7 factorial, 7 factorial times 3 factorial, same thing, right? Multiplication, 2 times 3, 3 times 2. So that's why you're going to end up with the same answer. And it only works with C's, it does not work with P's. So say I gave you this, 20C14. What would that equal? 20C what? 6. 20 minus 14. The difference of the two. Yeah? C is also weird. They have a formula on your formula sheet over here where they say NCR equals N over R in brackets. So instead of writing NCR, they could write it like this. So instead of writing 20C14, they could write it like this. 20 and 14 in big brackets like this equals 20 over 6. So instead of writing it with a C, they can write it like that. It's on your formula sheet. So if you forget what that stands for, you can look on your formula sheet, right? Like it shows you it's C. Yeah? Kind of sense? Okay. Next page. So note when you have restrictions and combinations, that just alters what you're choosing from. So here we have, and it's not on this one, but it might be on the next. To win Lotto 649, a person must correctly select 6 numbers between the numbers 1 and 49, inclusive. Jasper selected the 6 numbers of the birth dates of his family, 3, 7, 9, 11, 20, 29. How many different selections of numbers could he have made? So how many, does the order, and this is the thing, the order in which you pick the numbers for the Lotto 649 doesn't matter. If you went to actually pick your own, you'd go to this little piece of paper, I assume. I haven't done the Lotto in a very long time, but you used to go to this piece of paper because my mom sold lottery tickets, and you would just like bubble the 6 numbers you wanted. And they were in order, 1 to 49. You just bubble the 6 you wanted, and it would go through this machine, and it would go, and then it would print you out a ticket with those 6 numbers on it. So the numbers on the ticket are always in order, lowest to highest, okay? The orders that the 6 numbers that randomly get selected for the Lotto 649 can come out in any order, right? They don't have to match your ticket. Your ticket is always low to high, so there's no like order doesn't matter in which those 6 come out. You just have to match the 6 numbers. Okay? So it's a combination because order doesn't matter. How many do I get to choose from? 49. And if you don't know, make it smaller. Instead of 1 to 49, make it 1 to 3. 1, 2, 3. 1 to 3 is 3, so 1 to 49 is 49, right? Like you don't have to count the 49 yourself to know it's 49. 49C what? How many am I picking? 6. So type that in. I think it's 13 million something. Yeah. Almost 14 million. So a lot of people say, I'm going to win the lottery. Well, you have a 1 in 13 million, almost 14 million chance of winning it. It's actually worse than that, in kind of. Because some people say, well, what if 13,983,816 people bought tickets? Someone would have to win. No, because the moment 6 numbers aren't picked, it doesn't like block those 6 numbers from being picked again, right? So there could be like 100 people with the exact same 6 numbers and 0 people with the correct 6 numbers. So that's why the lottery isn't always won, even if that many people bought tickets. Okay? Canada's not huge though, so like everyone will have to buy a ticket in order to win anyway. Okay? If you go 49 P6, it becomes billions, not millions. So it'd be crazy. No one would ever win the lottery. Okay. Now, everyone, how can I guarantee getting a puppy? Do I just choose it from like all the animals in the world and then I guarantee getting a puppy? Could I get a puppy if I choose it from the animal? Chose it from all the animals in the world? I could get a puppy. How do I guarantee getting a puppy?
From the puppy.
To take it from the puppies. How do I guarantee getting a teacher? Choose it from all the adults in the world? Choose it from the teachers, right? So when you're doing these, if you want to like have 7 adults and 4 kids, you have to choose the adults from the adults and the kids from the kids. That's the only way you can guarantee getting adults and kids, correct? Or if you're looking at a deck of cards and you need 3 clubs and 4 spades, well then the clubs have to come from the clubs, the spades have to be chosen from the spades. That's your only option. You're not guaranteed getting them. All right? So that's why up here that says when you have restrictions with combinations, that alters what you're choosing from. Even if there's 52 cards in a deck, if I want diamonds, I can only choose from the diamonds. I wouldn't choose from 52 cards. There's no guarantee I would get diamonds, right? But if I took all 13 diamonds out of the deck and then chose 5 of those, then I would guarantee getting 5 diamonds. All right. So here we have the athletic council decides to form a subcommittee of 7 council members. So I need to have 7 people on this. Then I always have to say, do these 7 council members have anything different or special? So if they have jobs, then it would be a permutation. If they have nothing special, it's a combination. Order doesn't matter. So let's keep reading. 7 council members to look at how funds raised should be spent on sports activities in the school. There are 15 athletic council members, so there's 15 total, of which 9 are males, 6 are females, and the subcommittee must have exactly 3 females. Is there any jobs on this subcommittee? Did it list anything different? No. So we know that it is a combination, okay? If there was no restrictions about exactly 3 females, we would just go 15C7. Take the 15, I choose 7 members, and I'd be done, correct? But this one is more specific than just I want 7 council members, which would be 15C7. This one wants exactly 3 females. So I know I want 3 females, and then a lot of people will just say, okay, well that's 6C3, I'm done. You're not done though. Why? How many need to be on this subcommittee? 7. How many have I chose currently? 3. I chose 3 out of 6, but I've only chose 3, correct? So how many more people do I need? 4. Now if it said a difference, like I could have some other females, that's fine, but it says exactly 3 females. So what do the 4 have to be? Males. So I'm going to go 3 females or 4 males, or 3 females and 4 males to make 7. And. Yeah? So and means I do what? Multiply, because and add don't go together, they're too similar. I want to guarantee that I get 4 males. So what do I have to choose from? The 9 males equals. Now the cool thing about your calculator is, with C's, you don't need brackets. No matter what calculator you're using, you can type it in just like that. Because if you go 6 and you go C and you go 3, it takes the 6 and the 3 and it squishes it with the C. It doesn't, like it has no other option. That's what the C needs. It needs a number in front and a number behind. So you don't need brackets. You can literally type it 6C3 times 9C4. Every calculator in this room will do it that way. Pardon? Okay. Let's look at this one. Example 4. A class consists of 5 girls, 7 boys. A committee is to be formed consisting of 2 girls and 3 boys. Determine the number of ways a teacher can choose the committee if there are no further restrictions. Is this a perm or a com? Com, because they don't have jobs, right? Nothing's different for them. So I need to get 2 girls and 3 boys. How do I guarantee getting girls? Choose from the girls. How many girls are there? 5, C, 2. If you haven't noticed, the C is up and the 5 and the 2 are subscripts. So it's 5, C, subscript 2. And means I multiply. And how many boys? 7, C, 3. Type that in.
Is there a difference between 7C3 and 3C7?
Yeah, 3C7 won't work because you can't have 3 and choose 7 objects. Your n has to be equal to or greater than your. You're right. It's probably you're not bumping down. I bet you're not. It's subscript. Yours is subscript. Yeah, so yours is popping down. You need to arrow back up. So you go 5 now. These are actually each arrow back up. So if you're getting 0, what's happening is this is where TI-83s actually work better. It's rare, but they work better. You go 5C2, it's subscripting you, right? So it's 5C, and it'll subscript you as a 2 if you're a TI-84 or the the fancy ones, plug-in ones. And then it'll go times down here, and then it subscripts you again, 7C3, and you're like down like this, right? So what you actually have to watch is you have to arrow back up so that the times is actually up here. And then you do 7C3, and then it'll get you the actual answer. What is the answer? 350. Okay. Now we have Johnny, the principal's son, has to be on the committee. How do we guarantee getting Johnny? So you choose from Johnny. So in order to get Johnny, we have to have Johnny. What else do we need? We need 2 girls and 3 boys. Johnny and what? 2 girls and 2 boys. It says I had a Johnny in my university classroom. So yes, they do have Swift. So Johnny is 1C1 and is multiply. How many girls are there? 5. Yeah, 5C2 and watch yourself. How many boys? 6. Because you already chose one of them. His name was Johnny. So it drops how many you choose at the end, but it also drops how many you choose from. So that's why it's set up there with restrictions. Sometimes it changes your choices. Who you're choosing from. What do we get? 150? Do you have to put 1C1 into your calculator? No, it's only 1. 1C1 is 1. You have 1, you choose it. Like if I choose Johnny, it's 1 way. I just hi Johnny, you're mine. Yeah. Yeah, as long as you. All right. We're going to talk about cards. So cards are combinations. The only one I can really think of quickly was like war. War, you would play the cards which was given to you in the order. But most cards, once you're dealt, like even Uno cards, when you're dealt Uno cards, you just pick them up and only hold them where they're at. Like you just pick them up and you just hold them. Uno cards. Crazy people do that. Crazy people just hold them the way they are. Most people organize them in like suits, colors, stuff like that, right? And I can say crazy people because my youngest daughter does that. She just picks them up and she plays them how they are. And so actually, I thought she was crazy, but she was smart because I was like, oh, she has no blue left because she's pulling from the blue spot. No, she had plenty of blue. They're all over the place. She doesn't color for it. So it's actually smart. It's like a little tactic, really. All right. So the moment, because you get 5 cards dealt to you and you can move them around, the order in which they were dealt to you didn't matter because you moved them and you can play them in any order you want, right? So cards are combinations. Now on a test, if you called me over and were like, Mrs. Lepp, where can I find the factorial button? I'm going to walk away. If you said, Mrs. Lepp, where can I find the combination button? I'm probably going to walk away. If you said, Mrs. Lepp, how many spades are in a deck? I'm going to tell you 13. Because I can't have you get a question wrong just because you played cards less than someone else. Okay? So if they do it on a diploma, they have to give you like this much information, or they'd have to give you like an array of cards, or they just give a completely different set of cards, like a deck of cards, the suits are blue, green, purple, and orange, and they're numbered 1 to 10 or something like that. So that it's a deck that no one has ever seen before and no one has it up on people. Okay? So if you're like, how many face cards are there? I'll tell you there's 12. Right? So if you were stuck on something like that, I would help you out. Okay? So there are 52 cards in a deck, of which 4 suits, spades, clubs, diamonds, and hearts. Each suit is 13 cards, because 52 divided by 4 is 13. 2 suits are black, spades and clubs. 2 suits are red, diamonds and hearts. And face cards, the ones with faces, jack, queen, king. If there's 3 and there's 4 suits, 3 times 4, there's 12 face cards. Okay? Poker is a card game played from a deck of 52. How many different 5-card poker hands are possible? So we're choosing 5 from how many? 52. They didn't ask anything else. So 52 C5. A faster way, if you have C's on your screen, just so you know, if you have the TI-84s or these ones, the plug-in ones, TI-4CEs or whatever, you can just go up one, steal that C, and fill in the numbers, like refill in the numbers. Do that, so you don't have to use all of that. 52C5 is 2,598,960. So there are 2,598,960 different 5-card hands you could get from a 52-card deck. Okay. The next one asks, how many of those hands are all diamonds? So that means they want us to choose 5 diamonds, correct? How can I guarantee getting diamonds? Choose from the diamonds. How many diamonds are there? 13. So we're going to go I'm going to steal my C from above. 13 C5. I get 1287. So substantially less card hands have all 5 diamonds, correct? Out of the 2 million, which makes sense. I want you guys to try 2, 3, 4, and 5. Go. So we know, and this is what I always do to help myself, I know I need 5 cards. Every time I do this, every time I make choices, I need 5 cards. 5 happy cards. Okay? So the first one, all diamonds, I chose 5 cards. The second one, 4 black cards and 1 red card. How many cards is that? 5, so that's a good thing. So black cards, half the deck, 26C4 and 26C1. You guys can figure the answer to that, that's fine. 3 kings and 2 queens. How do I guarantee getting kings? From the kings. And 3 and 2 is 5, so we're in a good boat. So we have 4 kings, we choose 3. How many queens are there? 4, and we choose 2. Okay, what's the problem with 4? There's only 3 cards. And I need 5. So I need 2 whats? 2 not whats? 2 not kings. Correct? Because I need 3 kings, and the other 2 just need to be anything but kings. I'm not allowed to have more kings. Correct? So it'd be 3 kings and 2 not kings. So you have to make sure you always have 5. Okay, now watch yourself, because little Crystal remembers doing this and messing up. So 3 kings. How can we choose kings? We go 4, choose 3, and now keep in mind, everyone paying attention, a lot of people will tell me that it's 49, choose 2, but that's wrong. They're like, well, I only used up 3 cards. But it has to be 48. If you use 49, you could get another king, and we're not allowed to. It's not kings, correct? So what we have to do to get the not kings is we do 52 minus the kings, and we're left with 48 that we can choose from, correct? So we do 48, choose 2. Now we're looking, you guys can do the answer to them, that's not the problem. 4 aces. What's the problem with 4 aces? I need what? I need 1 what? And 1 not ace. So how many aces do I have to choose from? 4, and I choose 4. And is multiplied. How many not aces exist in the deck? 48. Which is 48, this answers. I can do that. 5 cards of the same suit. 5 cards of the same suit. Does it say what suit? So I just need to pick 5 from a suit, yes? So I could do clubs, I could do hearts, I could do spades, I could do diamonds, so I would have to add them. So if I want 5 clubs, I would go 13C5, correct? If I want 5 hearts, I would go 13C5. 13C5, 13C5 for the different suits. So instead of doing that, what might be a faster way? Yeah, 13C5 gets me 1 suit. There just happens to be 4 of them, right? So we could just go 4 times 13C5. If you flip over, I'll come back to that in a second. These 6 questions are the ones you have to do, 1 to 6. Reminder, the answer key, the worked out solutions are in Google Classroom, right? That's where you find out if you're right or wrong. So it's 1 to 6 on the next page. Yeah.